So in this video, I'm just going to be going over the 1 divided by 0, or even in any case, if we have any number divided by 0, right? And why it is undefined. Now, right now, what I want to do is, I just set up like a multiple choice, right? To answers that people will get confused by. Let's say if you didn't know that anything divided by 0 is undefined, then sometimes students would say 0, right? Because they would think, oh, because there's a 0 in the fraction, then it must be equal to 0. But that's wrong. And then some calculus 1 students would say maybe positive infinity, which they would get mixed up with, and then also negative infinity, which they could also get mixed up with. But in this video, I'll be going over why we can't use these solutions over here. So what we are going to do is the following, right? So first of all, on your calculator, and let's just start with elementary level mathematics. If you put on your calculator 1 divided by 0, or any number divided by 0, you will just get an answer of undefined, right? Or whatever calculator you would have, it would be math error, right? But let's just look at this in more detail, right? Of course, this is the logical answer, which is undefined. But what I want to do is the following. Throughout this video, I'm going to assume that you have knowledge on functions and the hyperbola in this case over here. So what I'm going to do is I'm going to take this, I'm going to put it on this side here, right? Our solution here for now. But let's consider the following function of a hyperbola, right? We have our y-axis over here. I can assume that you're in 10th grade in, depending on which state you are in, right? If you are maybe in like America or whatever, right? You will at least have knowledge of the hyperbola. Now let's look at our hyperbola, right? But first we need to actually make the function before we can plot the stuff in the Cartesian plane. So as you can see, 1 divided by 0, or 1 over 0, we can just, what we do over here is we're going to replace the 0 with 1 over x. We're going to replace it with x, right, the 0, such that we will have a function in terms of x, which is equal to 1 over x. And this is actually our rational function, or our hyperbola function. Okay, now what I've done over here, right, was I let 0 equal to x in this case over here, so that I can look at the hyperbola and just look into more detail on why it can't be equal to 0, or why 1 over 0 is undefined. So let's consider the following, right? We see over here that our a value, which is that one over there, this is represented as an a value, it's positive. So therefore, it will lie in quadrant 1, and it will also lie in quadrant 3. And because of that information that we have over there, we also need to look at the shifts. Are there any shifts? Well, we can clearly see there's no horizontal shift. It's adding by 0, right? Or there is no horizontal shift, and we can see there's no vertical shift. So therefore, it will just be our standard hyperbola. So let's draw our hyperbola. So it'll look something like this, right? We have two asymptotes. Now our asymptotes goes as follows. We have our asymptote over here, which is y equals to 0, right? That's our equation, which is exactly on the x-axis, like that, basically, right? It is exactly on the x-axis over here. And now x is equal to 0 line, which is exactly on the y-axis, like that. Okay, so there are our asymptotes right here. Now we need to draw our hyperbola, which mustn't touch any of these axes. So we're going to have something like this, maybe. And it infinitely goes towards the x-axis, but it never touches the x-axis. And it also never touches the y-axis in quadrant 1. And we're going to do exactly the same thing over here, but with the other one, with the third quadrant. Okay, and then we have our function f, because we're naming it. So now what I want you to look at, right, is we want to observe this hyperbola, and we're going to look at the x value, right? We're going to plug in our x value of 0, right? Or sorry, let me do it like this. So we're going to plug 0 into that x value, such that we'll get 1 over x. 1 over 0, right? And because we are letting x equal to 0, that will be our y-intercept. Am I right? Or are you following? Yes, you should be. So this y-intercept, meaning that it will probably touch any point on the y-axis where x is equal to 0. Exactly what is explained here. But what we can see is that it's actually not touching the y-axis. It is infinitely going towards the y-axis, but never touching it. It's such a small x value, like let's say 0,00001 from the right-hand side here. And at this side, where it's actually approaching downwards, this side around here, from the left-hand side, it's approaching negative 0,00001. Such a small number. It gives infinite amount. There's an infinite amount of numbers in that irrational number, but we don't know what that number is. It's so many digits. That's all I can say. So that is where I'm going to now bring in the. So now at least in an elementary way, you can actually see why we can't actually define 1 over 0. Because it will never touch the x equals to 0 line, right? But now let's actually take it up a notch. Let's look at these two. Why are these two in here? Now, the reason why I wanted to do it is because if you're a Calculus 1 student, you would look at it like this, right? You would actually take the limit as x approaches 0. But you won't just take x approaching 0, because obviously if you say of the function, so remember that you will have a limit in the form of limit as x approaches a of any function, which is equal to our limit value, right? And in our case here, our a value is 0, because remember we are going to look at where x approaches 0, and our function over here is 1 over x. So we're going to replace f of x with 1 over x. And our limit value is supposedly undefined. But let's first confirm this first. So what I want to do is the following. Let's consider the limit as x approaches 0 from the left-hand side. Now the reason I'm taking this approach is because if we are trying to prove that a limit exists, we have to prove that the limit as x approaches any number from the left-hand side is equal to the limit as x approaches any number from the right-hand side. And if it's not equal to each other, therefore the limit does not exist. DNE stands for does not exist. Okay, but let's just do that first, right? So we're going to take the limit as x approaches the left-hand side of 1 over x is equal to, and then what we're going to be doing over here, or let me write by equals to, we're going to take the 0 from the left-hand side into the x. That's going to be 1 over 0 from the left-hand side. So what we are exactly saying is that the limit as x approaches 0 from the left-hand side, we are mainly talking about from the left-hand side. So we can see that in the x, right, when we look at from left to right, we can see, oh, it's going all the way. Whoa, it's never going to touch this. It's never going to touch this y-axis. We've just established that just now. So that's exactly what we're going to say over here, right? And the reason and how we're going to get our answer is from our limit value. We know that our limit value is actually going to be our output. So our input, right, was our 0 from the left-hand side. That was our input, which is this exact thing over here. So our output, which is going to be somewhere in the y, right, which indicates the y-axis, right? So we can clearly see that it's going downwards. When we're looking at our y, we're looking either up, or we're looking down. In this case, we're looking down because we can clearly see that the function is going downwards. Now we can see that it's going all the way to negative infinity, right? It's infinitely going down in the y as x approaches the left-hand side. So that is why we say this value is equal to negative infinity. If you didn't catch that, I do recommend going backwards because I might have gone a little bit fast, but if you understand, good job. Now let's look at it as it approaches the right-hand side. So the limit as x approaches 0 from the right-hand side of 1 over x, we're going to substitute this into the x, the 0 from the positive side. We're going to get 1 over 0 from the positive side. Now what I forgot to actually mention, right, 0 from the left-hand side, meaning that any number that is so close the closest number to 0 from the left-hand side is obviously going to be negative 0,000 all the way to 1. Because that is the closest value that we can get to 0 from the left-hand side. If we look at our number line, I'm going to bring the number line into this. We have 0. And then we have some value over here that is so damn close to this. I apologize for that. That is so close to the 0. Like, okay, let me overemphasize. It's like right somewhere here. Like, it's literally almost touching the 0. Obviously, I can't visually represent it, but I hope you get the understanding. So that is what we are saying. And if we're talking from the right-hand side, it should be the closest value from the right-hand side of 0, which should be a positive number. So somewhere like here maybe, which should be equal to positive 0,0000000 and that should be some answer. And as you know, according to our fractions, when we have 1 divided by a super small number, we will have such a huge number, right? Do it on your calculator. Say 1 divided by 0,1 and then write down that answer. Then keep writing the denominator with such a small number like 0,01, then 0,001, and then see what values you get. And then you'll see you'll get such a large number. And that is why if we plug in this value over here, that number is so large that we can't even describe it. So that's why we call it positive infinity. And the exact same thing applies to this one here. Okay. And obviously, if you want to look at it in the graphical perspective, let's look at the limit value here, right? When we are approaching 0 from the right-hand side, like this, we are obviously not going to touch the y-axis. But what we notice in our y-axis, this arrow here indicates that we are approaching positive infinity. It's indicating the y. That will be our limit value. So that is why I say that that is why the answer is positive infinity as well. So there's 2 ways we can look at this answer. So now, for the moment of truth, does this limit exist? The limit as x approaches 0 from the positive side, the right-hand side, and the limit as x approaches 0 from the left-hand side. Do they equal? This one is negative infinity, this one's positive infinity. Therefore, negative infinity is not equal to positive infinity. Therefore, the limit does not exist. So we write this down. DNE. The limit as x approaches 0 from both sides of 1 over x does not exist. And that is why we have an undefined answer in a calculus 1 perspective. If you are looking at limits or if you are looking at a graphical perspective in terms of the hyperbola or the rational function. So which answer can it be? We know it cannot be positive infinity because it can only be positive infinity if we are talking about the value where x approaches the right-hand side. And here, it can only be negative infinity, so it can't be negative infinity in our case because we are not talking about as it approaches 0 from the left-hand side. So it can't be negative infinity. And 0, we can't say it's equal to 0 because we know that any 0 divided by any number is just going to be equal to 0. But it's the other way around. And like I've just described here in the graph, it cannot be equal to 0. So therefore this 0 can be eliminated. Therefore, it just leaves us with this answer of undefined. And we have literally been getting that in the entire time, especially according to the graph and according to our limits. So that is why x cannot be defined. That is why 1 divided by 0 does not have an answer. I hope this video actually enlightened you about this knowledge. Feel free to debate on this one. I actually don't mind. I'm actually interested to see you guys, your guys' comments on this video. Otherwise, stay tuned for the next few videos. I'll be making more videos on calculus. And thank you so much for staying tuned into this video.